Hi everybody, in this video we'll learn how to draw Lewis dot diagram. Sometimes you hear the structure, Lewis dot structure, but for preciseness, diagram is used when we are talking about single atom. But if we represent more than one atom like a molecule, this is Lewis dot structure. This is a structure. Sometimes we use structure for both, but today we will learn to draw those dot diagram for single atom. By the end of this video, you will be confident drawing this type of structure. The Lewis dot diagram is very important, and it is the nucleus or the core for many other topics. So you need to concentrate very well in this video. This will be a short video, but it will be a link for many other videos and many other topics. Let's define Lewis dot diagram. A Lewis dot diagram is a simple way to represent the valence electrons of an atom, ion, or molecule. To do that, this uses a diagram showing the chemical symbol with dots surrounding this chemical symbol to represent the valence electrons. The valence electrons are the outermost shell electrons. Let's talk more about the valence electrons before we continue. Let's consider this atom. This atom has an electron configuration of 282. So its outermost shell is occupied with only 2 electrons. These 2 electrons at the outermost shell are called valence electrons because this outermost shell is called the valency shell. So the valence electrons are the electrons that exist in the outermost shell. Using these valence electrons, we can predict how the element will chemically react, how an atom of this element will form a bond with another atom. Also, the valence electron can be used to predict the time of the resultant ion if formed, whether this atom will form a positive or a negatively charged ion. The outermost shell, the valence shell, predicts the physical and the chemical properties of the element. How can we represent the Lewis dot diagram? And what is the importance of Lewis dot diagram? Lewis dot diagram can mainly be used to show the valence electrons of the atom of an element. It is also useful because only valence electrons are used to bend to form molecules. Lewis dot diagram can be used to predict the geometry of the molecule. Lewis dot structure is also useful to show how atoms are arranged in a molecules. It also may explain stability of the atom, and it can predict the bonding of an atom, whether this atom can bond to another atom with a covalent or an ionic bond, whether it can accept or donate electrons. How to draw a Lewis dot diagram or structure? First, you will need to write the element symbol, and then draw one dot for each valence electron around it. Let's consider we have an atom X with 5 valence electrons. So we will draw the atom symbol X, and then we will draw a dot for each valence electron. But to draw those valence electrons, is it random or it follow a special structure? First, the dot should spread over the 4 sides, unpaired. So if we have this X atom with 5 electrons, we will draw first an unpaired electron in every side of the 4 sides of this atom. And then you can start pairing if you still have more electrons. We have 5 electrons, so we still have an extra one, so we can pair it here. Dots are not paired until all sides have at least one dot. Like this, we start by drawing the first electron, second, third, fourth, and then we will start pairing every one later. And we will start pairing every electron if we still have more electrons. Let's have an example. Let's see this atom. The electron configuration of this atom is 287. It has 17 electrons. This is chlorine atom. To draw the Lewis dot diagram, we write the symbol of the chlorine, Cl, and then we have 7 electrons at the outermost shell, 7 valence electrons. We will draw them first unpaired electrons in the 4 sides, one in every side. We still have 3 more electrons because we have 7 valence electrons. So we will start pairing electrons. And this is the Lewis dot structure of chlorine. This structure will tell us that we have one unpaired electron in this atom. This atom can form a single bond with this electron. Also, the valency of this atom is univalent. This atom is univalent because it has only one electron free to react. Let's have another example. Oxygen. Oxygen has 8 electrons. So the electron configuration will be 2, 6. The outermost shell has 6 electrons. We can draw the Lewis dot diagram. It is better to start drawing, to have a piece of paper and a pencil and start drawing before me so you can practice. It doesn't matter if you make mistakes. I don't care about that. What I care is just to practice, and if you have any mistake, you can simply correct it. We are learning from our mistakes. So I will draw the O, the symbol of the atom, which is oxygen, and I have 6 here. I will draw first one in every side, one electron every side. Now we have 4, we still have 2, so we can start pairing. The information that I get from this Lewis structure is this atom is divalent. It has 2 unpaired electrons. It may form 2 bonds or a double bond with another atom, and it can accept 2 electrons to reach to the octet rule. Potassium has 19 electrons. The electron configuration is 2881. So the outermost shell has only 1 electron. You can see it here. So if we need to draw the Lewis dot structure, we can draw it like this. It doesn't matter which direction or which side you draw this single electron. This atom is univalent because it has only unpaired electron. It has only an unpaired electron, so it is univalent. The valency is 1. Nitrogen. What do you think about nitrogen? What is the number of electrons? Perfect, 7. From the atomic number, it has 7 protons, so it has 7 electrons. So how can you configure these 7 electrons? Excellent, 2 and 5. So the first shell has 2 and the second and the last shell has 5 electrons. The valence shell has 5 valence electrons. How to represent it in Lewis dot diagram? We will draw the symbol of the atom, which is N, and then we'll distribute the 5 electrons. Let's have unpaired electrons over the 4 sides. So now we have 4 electrons. We still need to add 1 electron because this is 5 valence electrons. From this structure, we know that nitrogen is trivalent. The valency is 3. It can form 3 bonds or a triple bond. Why? Because it has 3 unpaired electrons. Magnesium. Let's pause the video and try to draw the Lewis dot structure of magnesium. Now, magnesium has 12 electrons. The atomic number is 12, which is the number of protons, which equals the number of electrons. So the electron configuration will be 282. The valence electrons are 2. To represent these valence electrons in the Lewis dot diagram, we draw the symbol of the atom, which is Mg, magnesium, and we have 2. We will draw unpaired electron here and an unpaired electron here. What do you think about the valency of magnesium? Yes, it's divalence. Why? Perfect, because it has two unpaired electrons. And these two unpaired electrons can be involved in the chemical reaction, can form a double bond or can form two bonds. This is your turn, guys. This is your homework. Take screenshots. Try to draw the electron configuration without looking at the drawing here and draw the lowest dot structure for the calcium. Find out the number of protons, the number of electrons, and the number of neutrons. Also, you have another homework here. This homework is a collective homework to revise the atomic structure, the electron configuration, and atomic number and the mass number. So for all the examples that you can see here, all the atoms that you will see, you need to tell how many protons, how many neutrons, and how many electrons for each atom to draw the Bohr's model and the Lawes dot diagram and to state the valency of each. Sodium, chlorine, you can take a screenshot or you can write the element. Hydrogen, boron, and oxygen. Now you have 6 atoms to finish as homework. You can write your answer in the comments down below. That's all for today, guys. Thank you. See you next video.